5.6. We're still talking about functions. Functions we're talking about today, though, we're talking about inverse. So we're going to talk about how we find and what it means to be an inverse relation and inverse functions. Okay? So let's start with some vocabulary. Okay, that way if you see this vocabulary, you kind of know what it means. When we talk about the word relation, a relation is any set of ordered pairs where x is the independent variable and y is the dependent variable. So just a relation, a set of ordered pairs. You'll see in the first set of examples we have some set of ordered pairs. They could be written like this, or they could be written in parentheses, right? And then just in any ordered pair, x is generally the independent variable, and then y is the dependent variable. So y depends on the value of x. A function. You've talked about functions before. A function is a relation in which each element of the domain corresponds with exactly one element in the range. Okay, so we've done a couple of things to talk about whether or not something is a function. For instance, remember vertical line test? We've done vertical line tests this year, haven't we? I think. No?
Yeah,
Maybe?
at the very beginning.
I'm trying to remember. I don't know. Maybe, maybe not. I can't remember exactly for sure. But functions, if something's a function, it passes a vertical line test. Or another way I often talk about it is each x value pairs with only one y value. So basically your x values don't repeat. Each one is unique. Okay, so we'll talk about that. And then the big thing we're going to talk about is an inverse relation. An inverse relation is formed when the roles of the independent and the dependent variables are reversed. Well, if you remember, just up above, independent is your x variable, dependent is your y variable. And so if those roles are reversed, it's taking your x's and your y's and switching them. Okay? And then an inverse function can be shown using this f inverse of x notation. So when you put a -1 on that f right there, that is your inverse notation. Usually read it as f inverse of x notation. And that's just saying that it's the inverse function. Okay? Now, we got to start at like level 1, right? We got to start with the easy ones. Okay, you got a couple of easy ones in homework. Identify the inverse relation, and is it a function? Okay. So, what did it just say about inverse relation? An inverse relation is formed when the roles of the independent and dependent variable are reversed. So that's going to happen when your x's and y's are switched. Okay. So, we could do this as ordered pairs. I know in the homework they have you list ordered pairs, okay? But I'm going to go ahead and just set it up as an XY chart because that's what we're provided here. And this is the inverse. Guess I better label what we're doing here. Thoughts? If -2, 1 is part of the original function, what's going to be in the inverse? 1, -2. If -1, 4 is in the original function, what's going to be in the inverse? 4, -1. If 0, 3 is in the original, 3, 0 is in the inverse. And if 1, 1 is in the original, 1, 1 is in the inverse. Okay, guys. That's your inverse right there. Okay, as I said, in Savvas, they have you listed ordered pairs, so use parentheses and then put a comma between each parenthesis. Okay? Now, the other thing they ask is it a function? Okay? When we talk about whether or not something is a function, we talk about, does each x value correspond with exactly one y value? Okay, so what it talks about right here. A function is a relation in which each element of the domain corresponds with exactly one element in the range. So let's practice on the original. Okay. They gave us this original set of ordered pairs. -2. What does it pair with? 1. Does it pair with anything else? No. -1. It pairs with 4. Does it pair with anything else? No. 0 pairs with 3. Does it pair with anything else? And 1 pairs with 1. Does it pair with anything else? No. Okay. So each x value corresponds with exactly one y value. So this is an example, and I know they don't ask this, but this is an example of, yes, it is a function. Okay? Now, what they're really asking is the inverse. I was just using that one as practice. Is this inverse relation a function? So can I go through the same process? 1. 1 pairs with -2. Is that all it pairs with?
No.
What do you mean no? Okay. In this scenario, the x value 1 pairs with -2 and 1 pairs with 1. Does each element of the domain correspond with exactly one element of the range? No, because this particular x value of 1 corresponds with 2 different y values. Okay, so when you have an x value that corresponds with 2 different y values, this is not a function. Okay, so is the inverse a function? It is not a function. Okay. Questions there? Okay, ready to try B then? Okay, they give me a set of ordered pairs. I could read through those, but what's the point? You guys have them in front of you. What's the inverse?
9, -1.
Okay, we're going to start with 9, -1.
7, 0.
7, 0.
5, 1.
5,
3, 2.
5, 1. 3, 2.
1, 3.
1, 3.
-1, 4.
-1, 4. Okay, to get our inverse, it's just taking the x and y and switch them.
Oh my.
Okay. Now, the question is, officially is the inverse a function? I'm going to go ahead, let's just practice, the more practice the better here. Let's go with the original. Is this original relation a function? Yes, no? Does each x value pair with exactly one y value?
Yeah.
Basically, is each x value different? It is, isn't it? So is this a function? It is. And again, I know, not exactly what was asked. I'm just trying to, practice here. Here's the one that's asked. What about the inverse? Is it a function?
Yeah.
Each x value is unique, yes? If none of my x values repeat, we're good. It's when the x values repeat that you have to examine a little bit closer. So since each x value is unique, yes, this is a function. Okay? So you have a couple in homework. You have to type in the ordered pairs. I think they also ask you about whether or not it's a function in that problem. I don't remember exactly, but. Okay. This is the easy find the inverse. Switch x and y. Ready for next step up? Of course we are, right? Okay. Next step up is, okay, given an equation, how do we find the inverse? Okay. So, there's a few little bullet points here, kind of as your steps. And when we talk about finding the inverse, we're still going to switch x and y. The difference when we talk about switching the roles of x and y in an equation is you're going to physically switch the variables. X will become y, y will become x. Once we do that, we will then solve for y. And then once we get solved for y, in this case, I mean, that is your inverse. And in this case, we're going to also graph and look at the graph a little bit. Okay? Key thing it does talk about is the graph of a function and its inverse are reflections across the line y equals x. Okay, so that's just kind of a good piece of information to know. And I'll show you what that looks like. Okay, but a function and its inverse are going to be reflections. Okay. A, f of x equals x squared. They ask us to write an equation to find the inverse of f. We're going to graph f and the inverse of f to determine if the inverse of f is a function. Now, f of x equals x squared. What do we know about f of x? F of x is another name for y, yes? So first thing I'm going to do is I'm going to say, okay, f of x, I'm going to rewrite this as y equals x squared. Okay. Now, because what's the first step say then? In order to find the inverse, we're going to switch the roles of x and y. So, my current equation says y equals. Instead of y equals, y is going to become what? X. And then it says equals x squared. X squared is going to become y squared. Okay? So by taking your x and your y and switching them, that is your inverse. Now, so step 1, switch the roles of x and y. Step 2, solve for y. If I have x equals y squared, how am I going to get y by itself?
Factor.
Square root.
Okay. So it's currently y squared equals, yes? Basically, I need y squared to become y. And we can do that by taking the square root. Now, if we take the square root of y squared, we have to also take the square root of x, yes? Now, I should have written out, I'm going to back that up a moment. I'm going to show this in other stuff. I'm going to go ahead and switch this. I think it'll be easier for me to show here. But all I did was switch my sides. Y squared equals x, right? Still, in order to get y by itself, we're going to square root. Now, what is the square root of y squared?
Y.
It's y. Good.
G.
What is the square root of x?
X.
Square root of x. Now, small catch. When you take the square root in an equation setting,
Plus or minus.
what do we have to put in front of it? Plus or minus. So this is going to be y equals plus or minus the square root of x. Okay? So it's that little trick, it keeps popping up, doesn't it? Where in order to take a square root in an equation setting, you have to put in a plus or minus. Okay, so this right here is my inverse. Y equals plus or minus the square root of x. in Savas, you might see them using F inverse, and I think I talk about that on the back side of my notes a little bit. Yeah, I do. Okay. Now, it asks us to graph, yes? Okay. And it asks us to graph F and the inverse of F. So, let's start by graphing F. What do you know about y equals x squared? You know the graph of y equals x squared. X squared? What shape is that graph? A what?
A slope.
Parabola.
What'd you say now?
Parabola.
Parabola. I kind of thought that's what you had said earlier.
She said first.
And the first time, and it went gibberish into my head, and so I wasn't getting it. But, okay, parabola is what I'm looking for. Good. Okay. Now, if you guys recall when we did parabolas, we had kind of a basic XY chart. Do you remember any of that? We've slept too much since then?
One, two, four. 0, 1, 2, 4.
Yeah. And I'm going to set it up a little bit. I'm going to include some negatives as we talk about this. But, yeah, you've got the basic idea that I'm going to put 0, 0 here in the middle. We use 0, 0, 1, 1. What else did we use? 2, 4. And don't confuse this with the square root graph. The square root graph was backwards that we did at the beginning of the semester, or beginning of the 9 weeks, right? So just think, and we can put this in. If we put 0 in, 0 squared is 0. If we put 1 in, 1 squared is 1. 2 squared is 4. If you want to go one more, you could. What's 3 squared?
Oh my.
9. Okay. Now, I'm going to throw in a couple of negatives. Not that you have to, because you guys know our pieces just flip, right? Or the right half of the parabola looks like the left half of the parabola. But if we put in -1, what's -1 squared? +1. What's -2 squared? 4. And if I throw it in, what's -3 squared? 9. Again, not that you have to go all that way, but can you graph your parabola? 0, 0. Over 1, up 1. Over 2, up 4. And we don't usually necessarily do over 3, up 9, but I threw it in today. Okay? The left looks like the right, yes? Over 1, up 1. Over 2, up 4. Over 3, up 9.
Parabola.
Okay, there's your parabola. Okay. Now, while we're here real quick, let's talk about, is this a function? Does each x value pair with a unique y value? Yeah. 3 is only going to pair with 9. It's not going to pair with anything else. 2 is only going to pair with 4. It's not going to pair with anything else, is it? Or does this pass the vertical line test? Remember, vertical line test is, can I draw a vertical line through it and it just touches the graph once? Does it do that? Yeah. Okay. So, for the record, just throw it in here while I can. This is a function. Okay. Now, inverse. If we set up an XY chart for the inverse. This is indeed what we did at the beginning of this 9 weeks. Okay, but we can also just use this equation here. If we put in 0, what's the square root of 0? 0. Now, what if we put in 1? What's the square root of 1? 1. What's in front of this 1 though?
Plus or minus.
Plus or minus 1. Do you want to put in 2? I personally will pass. I don't want to do the square root of 2. What's the next number we like doing the square root of? 4. What's the square root of 4?
2.
2, and since there's a plus or minus, we're going to say plus or minus 2. And the next number we'd put the square root in?
9. Oh.
9. What's the square root of 9?
3.
3. So plus or minus 3. Now, okay guys, is this XY chart, the original XY chart, flipped?
Yeah.
Think about it. It looks different, but it is, isn't it? I wrote it different. It's just, it's flipped. Okay, let's graph this, see what it looks like. So 0, 0, we know where that is, right? Now, when we say 1 plus or minus 1, do you realize that that is the ordered pair 1, 1, and it's the ordered pair 1, negative 1. So I'm going to graph 1, 1, which is right 1, up 1. I'm also going to graph 1, negative 1, which is right 1, down 1. You see that? Okay. What about 4 plus or minus 2? I'm going to go what? Over 4, up 2. And I'm going to go over 4 and what?
Down 2.
Down 2. And can we do it again? 9 plus or minus 3, so over 9, up 3, over 9, down 3. What is this? What shape is this? Is this the same shape we just drew right side up? Right side up is a parabola. Is this still a parabola? Yeah, it's just on its side. Okay. Now, we're still drawing our sideways parabolas, aren't we? Our next question, is this sideways parabola a function? So 2 questions you could ask yourself. Does each x value pair with exactly one y value? Or does it pass the vertical line test? Does it pass the vertical line test? Can I draw a vertical line that touches the graph just once? No, when I draw a vertical line, it's going to touch the graph twice. Or, what do you notice here? The x value 1 pairs with what? Positive 1 and negative 1. So that x value of 1 pairs with more than one y value. So for both of those reasons, this is not a function. I guess I'm not sure if it ever asks if it's a function or not. I think I'm just taking advantage of the opportunity to talk about it. Okay. Now, Eventually we're done with this problem, but one thing I want to talk about, okay? It says to graph them to determine if the inverse of f is a function. Oh, I guess we did do that. We did have to do that. But up here, third bullet point back up here, the graph of function and its inverse will be reflections across the line y equals x. Well, the line y equals x, and you can choose if you put this in, but the line y equals x is a line that goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and so on and so forth that way too. Okay? Now, I'm just doing this as a dotted line here, but here's the idea. This function and the inverse, so those two parabolas, are reflections across that diagonal line. Meaning, if I could take my bin Q and I could fold this along that diagonal line, what should happen with those two parabolas? They'd line up, right? They'd land on top of itself. If I take my notes paper and I fold it along that diagonal line, granted, it's hard to do because for me I have stuff written on the back, and I'm not going to be able to see, but if I fold it on that diagonal line and I hold it up to light, I should see my parabolas lining up on top of each other. Does that make sense? Okay, so that's the idea that a function and its inverse are reflections across the line y equals x. Easier said than done to demonstrate, isn't it? Okay, questions on this one? Okay, let's try B. Practice what we just did. First of all, we got to find the inverse. Well, what do we know about f of x? F of x is another name for y. So this is y equals 2x minus 1. Okay, how do I find the inverse? Take x and y and flip them. So instead of y equals, I'm going to write x equals. Instead of 2x minus 1, I'm going to write 2y minus 1. Okay? So there's the inverse. Now, we've got to solve that. How do you go about getting y by itself? Pause the divide. We'll divide here in a moment. What am I going to do before I divide? And I don't know, would it help if I go ahead and flip the sides here? Okay, that was weird. Delay in writing here. Let me flip the sides. 2y minus 1 equals x. How do you get y by itself? If it's 2y minus 1, we want to... How do we move the minus 1? We're going to add it. If you add 1 on the left, you're going to add 1 on the right. So now I have 2y equals x plus 1. Okay? And what's the next step?
Divide by
Yeah, divide by 2. Now, when we divide by 2, we could write this one of two ways. Could you write it as just one big division fraction? One big division fraction? That was horrible. Could you write it as one big fraction? One big division bar? You could. I'm going to say, and I'll put it over here, you could write it as y equals x plus 1 over 2. Now, for the purposes of putting it into Savas, Savas was happy with that when I tried it. Okay? However, in terms of graphing, I'm going to prefer to think slope-intercept. And so the other option is to divide both pieces by 2. if we think about 1x divided by 2, or in other words, if I divide each of these terms by 2, 1x divided by 2 is going to be 1/2 x, plus what do we have here? 1 divided by 2 is also 1/2. Okay? You can use either of those in Savas. When we go to graph this, it's going to be easier to use the one that's slope-intercept. Okay, but those are equivalent answers. Just depends on what you need, what information you need. Okay. And this is my inverse we were working on. Shall we graph? Go back to the original. Y equals 2x minus 1. What about y equals 2x minus 1? That's in what form? Y equals
X plus
mx plus b. Where what's m?
slope.
M is slope, and my slope here is 2, or 2 over 1 if you will. What's b?
Y-intercept.
Y-intercept, and it's a -1 there. You can graph this, yes?
Up 2 over 1.
From where? Where's my starting point?
-1.
Okay, so y-intercept -1. We're going to put a dot that is down 1. And then, I totally agree, slope of 2, rise 2, run 1. Rise 2, run 1. Rise 2, run 1. How many times do you want to do that? However many times you feel. I like to do overkill. But, I'll be honest, it helps me draw a straight line. Okay, I can't draw a straight line on this screen to save my life. So, it helps. You can also reverse it if you want, yes? Okay, so. See, even now I don't know that I can draw a straight line. Ooh. See, I can't even draw a straight line through my points. Gosh. Okay. This is why I put a bunch of dots. This is why on paper you can use a ruler, yes? Or some of you just don't care if your line is straight, so more power to you. Okay, so that was my original function, original graph. Hey, while we're at it, is it a function?
Yeah.
Yeah. It's a straight line. Each x is going to pair with one y. It passes the vertical line test. So yes, it is a function. Put that on the other side. Okay. Now, for this one here, I don't know, how do you feel about fractions?
Do you slip it? 1 over 2? Or, no.
Well, my only thing is we have a y-intercept of
No.
1/2 that we have to graph. Which, here, I'll be honest, Savas let me do that last night. I didn't realize Savas would let you do that. News to me. So, what else could you do if you don't want to do slope-intercept? Could you do an XY chart? Yeah. Put in 0. And I would even put in 0 here on the left. What is 0 when you put it in? 0 plus 1 is 1 divided by 2 is 1/2. See, we're stuck with fraction, you know. We can work with it. I like 1. Let's put in 1. 1 plus 1 is 2 divided by 2 is 1. Ah, there we go. That's a nice number, isn't it? If you put in 2, you're going to get a fraction. You can still do it if you want. 2 plus 1 is 3. 3 divided by 2 is 3 halves. 1.5. But if you put in 3, 3 plus 1 is 4. 4 divided by 2 is 2. The odd numbers appear to be working better, don't they? Okay. So if we do that, I have 0, 1/2, which is down here. 1, 1. Over 1 up 1. 2, 3 halves is going to be over 2 up 1.5. And 3, 2. Although I feel like did I graph that last dot wrong? I did. Try this again. 2, 3 halves. So over 2 up 1.5. There we go. Something's not right here. You guys didn't tell me I went down 1/2 instead of up 1/2. Can you even see that I did that though from where you're at?
No.
Redo. 0, 1/2 is up 1/2. 1, 1. Right 1 up 1. 2, 3 halves. So that's right 2 up 1.5. And 3, 2. Right 3 up 2. Okay. You could do other points. Basically, you're seeing a slope of 1/2. So take a whole point and just go up 1 over 2. Up 1 over 2. You can reverse that if you want. Okay. Okay. Is this a function? Yeah, it passes the vertical line test. Okay, so it is a function. It's a line. Okay. And just for reference, can you see how these would reflect across that y equals x line? Okay. And again, not that you have to draw that line in, but that is that reflection line, and I probably should go back up and label it if you did draw it in on the last one. Y equals x. Okay. Okay. I guess we're stopping here. With that in mind, you don't have up through 5.5 done. Get it done. Okay. We will work on finishing notes on 5, 6 on Monday and then go from there.